Good. So as we continue our last session about the Java multi-threading. Multi-threading. Sometime if you look you maybe on internet, you can find the terminology Java multi-threading or sometimes say Java concurrency. So like these are terminologies, somehow they are mixed. Many places are used, and sometime maybe someone say Java uh, multi-threading programming, or sometime someone say concurrency programming,
Right.
or sometimes say parallel programming.
Same thing.
I'm just going to depict what the meaning of. Okay, so Java have a programming model. You can say different programming model. Okay, and one way this, second way this, third way this. Okay, so lots of terminology sometimes confuse what the meaning of these terminology. So before starting our multi-threading, we understand what the meaning of multi-threading programming or concurrency programming or parallel programming. Okay, so all are terminology related to look like similar, but have a these two are look like a same something, and these are the something different. So and sometimes a many other terminology. These are two major. Okay, let's understand theoretically what do you mean by parallel or what do you mean by concurrency. The major challenges or confusion parallel versus concurrency. Parallel versus concurrency, right? Concurrency means the multi-threading. Both are the same thing, right?
Right.
So generally, let us understand this by example. Okay. So now let us currently we have a one CPU. Okay, one CPU, right? And one CPU have a generally have a multiple core which are generally executing your code, right?
Right.
And let's in the before going to the computation, let's the real life. Let's give we have a one person, right? One person, and we have another person, right? Okay, right? If two persons are independent, right? Both can work parallelly, right? That
Right.
means the same times a particular A instance, he is also working and he is also working, right? There is no any kind of a gap. Same time this is also working, this is also working, this is also working,
Right.
this is also working. Like
Right.
currently we have a, so this is known as a parallel programming, a parallel processing, right? Means ki particular works are processed by multiple person, right? So whenever more than one persons are doing some job, so same time you can say ki parallelly two things going on, right? Maybe three
Right.
or four, depend upon the number of person or people available. So
Right.
this is the concept known as a parallel. Parallel means just at the same time, at the same moment, more than one people's or persons working, right? This is
Right.
known as a parallel. But in the case of concurrency, we have only one person, okay, can do multiple work at the same time. That's simple. at present me, right? I am speaking, and maybe I can take tea, I can take water, right?
Right.
Whenever I'm teaching, might be chance ki I am taking a water. So whenever I am speaking, at that moment, I'm not taking a tea. Okay. Once take a one sip of tea and then speak. Again take a sip of tea, again work, right? So these works, speaking and taking water, is the two work. Is done by the same time by the one person, right? So this
Right.
activity is known as a concurrency. Means here speaking and taking water, right? Both
Right.
activity is going in progress by the same one person, but not at the same moment. Sometime speaking, sometime taking water. Sometime
Right.
speaking, sometime taking water. There are some interleaving. Whenever I am speaking, at that time I cannot take water, right?
Right.
Whenever I am taking water, at that time I am not speaking. But overall, two, speaking and drinking, two processes are continue in progress, right?
Right.
Both are going on. So such scenario known as a your concurrency, right? Might, so is it clear? In the case of parallel, there must be two people or three people, or maybe one person are just drinking water, one is just speaking, right? In the case both work like speaking and drinking water is going the same time by different people. So this is known as a parallel programming or parallel processing or parallel working. But whenever only one person are doing the two tasks same time, but not exact same time, but some interleave. So this is known as a concurrency word. So is it clear what do you mean by parallel? What do you mean by concurrency?
Okay. So parallel means you do two things at the same time.
Concurrency means I am only one person doing more than one job in one time. Maybe sometime first little bit time, then stop them, then little bit time them, then again stop them like this, then stop them, then again. This is known as a concurrency. Concurrency means ki only one persons are doing multiple job at the same time, but actually not the same time at a time one. First time little bit time give to one task, little bit time give to the this task, little bit time give to the this task, right?
Okay. Yeah.
This is concurrency. Concurrency means they have only one thread or only one resources, only one persons are started three tasks in the same time, right? But really, actually, at a time, this person can do any one of them, right?
Hmm.
But they give some time to here, some time to here, some time to here. So look like they have started all the three work in progress, in progress. So all three work is in progress by the one person.
Okay.
Is it clear?
And yeah, and the parallel.
Parallel means ki different peoples are doing different. Let's say same three tasks. One task done by this, one task done by this, one task done by this. The same time, three tasks is one progress, but no one is stopping. It's continuous going on. It's continuous going on. It's continuous going on. So here, what do you mean multi-threading means? Multiple work is going in progress by one thread. Yeah, one person is a concurrency. Multiple work going in progress by the multiple resources is a parallel processing.
Right.
So objective is, let's say we have a task one, task two, task three. I want these three tasks must be started today, right? So we have a two options. One is a parallel processing. I can hire three people. People one, people two, people three. Say, hey, start doing your work. Both work going to in progress, right? So this is known as a parallel processing. But a second scenario, I am going to concurrency. Concurrency say, I have only one person, but I want these three tasks must be start now, right? So this one going to start first this and little bit pause them and then going to start them, little bit later pause them, again going to start this, little bit pause them, again do this, again pause them, again do this, again pause them, again do this, right? So in this way, one person are started this job in the same time. So this concept known as your concurrency. Question is why? What the benefit of the concurrency? First things, we have a less resources, and might be this task, the task one is going on. Might be somewhere here, say someone ask, hey, type your password, right? So now at the time until user not types, your resources is waiting, right? Because this resource, work done by only one person. If this task is going to block somehow, your resources are still waiting, right? Not doing anything because they have not any other work to do, right? They have only one work. They have only one work. They have only one work. So here in the case of parallel processing, sometime our resources are not fully utilized. But in the case of concurrency, we are utilizing our resources highly. Clear something?
Yeah.
So same terminology here used for the threading. Thread means maybe we have a only one. Now here before in the real life example we're talking about the people or person. Here I'm talking about maybe uh, CPU core or computer, maybe two computer one and computer two, right? Here same time I start one program, I start one program. Both are running at the same time. This is the parallel processing, right?
Right.
Parallel processing might be option from the different computer, right? Or in the one computer also possible because nowadays our CPU have a 8 core, right? 8 processing engine, right? A 4 core. So now at a time I can start 4 job, right? I have 4 core. So parallel processing means one one person are doing only one jobs, not taking any other jobs. Similarly, in the case of thread, one thread just doing only one jobs. That is the parallel means. Concurrency means ki one person can simultaneously start multiple work, right? But some interleaving, some pause, some start, some pause, some start. In this way, fashion they are completing all these three tasks. So little bit clear what you mean by parallel processing or concurrency.
So parallel, it means that you use multiple thread,
Multiple threads, yes.
but in concurrency, you use one thread.
One thread, yes. And from one thread, I'm going to work multiple work, right?
Yes.
Yeah. So you can say let's give away three tasks. Yeah, three tasks. Task one, task two, and task three. We have a two option. One option I can create the three thread. Okay, one thread for this, one thread for this, one thread for this. Right? A three are
Right.
started the same time. Right? And
Right.
he complete his job. He complete his job. He complete his job. Right? This is the
Right.
best option. Right? Second approach, no, I'm not going to start three thread because this is a very simple work and one person can do. Why I going to use other three people, right? So I can say no, I'm just starting only one person, right? One person started this one, this one, this one. Some time allocate here, some time allocate here, some time allocate here. Little bit pause, then do this. Little bit pause, then do this, right? And after certain period of time, it will finish the work, right? The three work is finished by just only one thread, right?
Yeah.
This is the concurrency.
Right. Got it.
Clear?
Yeah.
And question is why we are generally prefer concurrency because let's give away these three work. Task work one, work two, and work three. So in this work means program, whatever written might be here. I'm going to call some third party microservice, or I am going to accessing some big file. I am going to maybe asking, hey user, can you prompt you type your username and password, right? So whenever our screen prompt type your username and password, at that time my threads are waiting, right? Until
Right.
user not type the value, right?
Right.
Until you are not typing the value, our highly used resources, highly capable resource just waiting for your input, right? So in this case, might be case these three are sometimes just waiting idle. So many times our CPU have a lots of speed and they work very quickly, and many times
Right.
they're just waiting for your input, right?
Right.
So why not I can utilize these resources? Why this thread just doing only one job? Whenever they are going to idle, they can pick start another work. Why not, right? Due
Right.
to that, we are going to use the concurrency. We are going to highly utilize our resources. Let us say we are hire some labor, right? And today labor going to start work, okay? And let's he want some maybe some material, and now currently let's get our material out of stock, right? So what, okay, our labor say just sitting, I am going to take out the whatever the stocks out. Once stock come, then he can start going to work, right? This is the one way.
Right.
And second option is, okay, let's this out of stock, let's you start this work, I am going to take out your resources, right? That means our labor are busy to another work, right?
Right.
So this is the concurrency. Concurrency means we are going to highly utilize our resources.
Got it.
In the real time, in the real example, people person, in the programming, known as a thread. Thread is a person. Just assume thread is a person. If one person at a time just doing only one job, that means simple like parallel processing. They're not doing anything. But sometime one person at the same time can do multiple tasks, 2 or 3 tasks, right? So this is known as
Yeah.
your concurrency. So concurrency just help us to highly utilize our hardware, right?
Right.
Good. So
Yeah.
these two terminology, be clear what is the parallel processing, parallel programming, multiple sometime word. So multiple processing, right? Parallel
Yeah.
processing terminology, or concurrency programming or processing, right? It's clear. So these are the basic concept of your multi-threading. Both the of the concept parallel or concurrency objective is to do multiple work. Here now multi means multiple work I want to do, right? So we have a two option. I can go with a parallel or with a concurrency. Parallel means we need a separate new thread for each work, right? Here say no, I am start only one thread, and one thread can do three work, right? Or four work.
Right.
So that is the concurrency. So simple. Concurrency means this is the only one thread can simultaneously start multiple work. Work
Right.
1, work 2, and work 3. Here, I want to start 3 work. Work 1, work 2, and work 3. So I will start a 3 thread. Thread 1, thread 2, thread 3, right?
Right.
So here 3 people are 3 thread will deploy work the 3 work, right? But here only
Right.
one person can complete my 3 work. Why? Because this my thread or person is very highly skilled, very capable, right? Due
Right.
to that, I am going to use this. If my person is not so capable, so I can again I want 2 or 3 work done within a defined time, right? Not
Right.
take a larger time. If our application taking larger time, that means ki our threads are not any uh, further space to do work on other work, right? Might be when they started work one, this is work is so highly calculative, very busy, and he is not able to take some uh, space, not take some time to give a look to the other work, right? So in this scenario, we have to introduce another thread, right? So depend upon our situation and scenario, right? So
Yeah.
notice in the computer there are two kind of processes can be. One kind of process is highly computation intensive, right? Means there lots of mathematical calculations going on, processing going on. That means here CPU our thread continuous busy to work. There not any space for wait, right? Some
Right.
types of work where our CPU not more involved. Sometime database call, sometime web service call, sometime file system read write, sometime input output. In this case, our system sometime our thread sometime get lots of space, right? A
Right.
time, idle time. So in this scenario, multi-threading is the best option. Concurrency is the best option. But the situation where your one thread are continuously involved the calculation of millions of records something in the CPU. So if some tasks are CPU intensive, means you always need the CPU. In those cases, parallel processing is highly effective, right? But some applications, some situation processing, generally in our case, always we need input from the different resources, right? Let's
Yeah.
we are reading some images from the different website, audio from different website, video from different website, from database call, from file system, from input output. So in this case generally lots of times our particular threads are waiting, right? So those idle things of the thread are going to highly utilize with concurrency. So the nature of our data, the nature of our processing, we have to decide concurrency or parallelism. If your computation is highly computation intensive, that means required lots of CPU time, then go with the parallelism. If sometime your applications have lots of waiting times, idle times, go with the concurrency, right?
Yeah.
So any doubt, confusion, what do you mean by parallel processing and concurrency? Now it's clear.
Yeah. Yeah.
Great. So generally, uh, whatever the we are going to the coming session, by default this parallelism is provided by the JDK to you, so you are not going to write any code, any things for here. Okay, all the things we are going to learn as a concurrency. The only why, because concurrency have a challenges, right? Concurrency have a only one resource, right? They want to work multiple thing, right?
Right.
They want to do one multiple time. So here maybe sometime this stop the job, do sometime this stop the job, do sometime do stop the job. Okay, so here lots of challenges, lots of problem, right? L- Lots of some we're going to cover in the future, but whole multi-threading course we are only going to consider this concurrency part. And parallelism is for you don't as a developer write anything, because what, just start new thread that they are doing independently, right? There is no rocket science for this. Java API by default provides a method. You want to parallelism, just say parallel streaming or parallel threading, just nothing. And all others, whatever the coming course we are going to understand, just understand the concept of your concurrency, what is the concurrency related problem, issue, how to this multiple job you're going to say, how this job completed, then what happened, how get the result, this job completed, then how get the result, right? So lots of plus minus challenges, advantage, disadvantage, the concurrency, a multi-threading concept have, which we are going to the cover in multiple classes, right? Multiple session. So just for theory, we have to clear what we are going to achieve.
Yeah.
Clear?
Yeah.
Good. So let us understand concurrency or multi-threading. The both are the same thing, right? Here, okay, same thing. And sometime you can say parallel, or you can say here say multi-threading, or here you can say uh, multi-tasking. Okay. This is the feature by default operating system support your multi-thread. Multitask, multiple tasks are going at a same time by the different machine, different computer, different people, different thread, right? This is the multitasking. So this terminology sometime different: multitasking, multi-threading, concurrency, parallelism. These are the related to the similar things ki multiple work going at the same time, right?
Right.
The design ki who is multiple work is done by the one person, multiple work done by the multiple person, depend upon the situation, depend upon the work we are deciding, right? There is
That's
no any
right.
hard and fast rule. What the nature of work you have to decide. Kya I'm going to take only one person for my work or 10 person, right? It's no
Right.
any hard rule ki whenever you are going to start your any work on your side, always you need to tell people, 10 people as a 10 worker, a 10 laborer you needed. No, there is no
Right.
rule. Nature of work, what kind of work in my house, right? According to I have to take the person, right? Similarly, in the case of programming, what kind of a logic, what kind of program you want to run is a multiple things, right? Accordingly, you have to use the tool.
Yeah.
Great. So let's see. Study I remember last class we had to understand how to create thread, right? How to create thread we have understand, right? I remember how to create a thread. Okay,
Yeah. So you use
so
the
we
class
have
thread.
understand one approach. One approach cover one first approach we covered. First approach by inheritance, right? By inheritance. Because we started notice the last class we have a write my own thread class and inherit from the existing thread class, right? So just remember like a class my thread, right? Have you remember?
Yeah. So you implement.
Extend 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 thread, because whenever here left side class, here must be the class if the extend keyword, right? Here class, here implement, that means here interface. You implement
Okay.
interface and extend always class, right? So let us say ki this is the way now. If I'm not writing this, my this is a simple class, right? There is no problem. This is a simple class,
Right.
and someone let's key hey my thread, okay, equal to new my my thread, okay. Now this is a simple class, but say just giving the name thread, it not become a thread, right? You cannot any option to here. There is no any option to my thread dot start. There is no method, right? How I can start? So we have to use the help of inheritance. I am saying, hey, this is my class. My class can become inheritance if I extend inherit from the thread class, right? Once you done, after that your class become a thread class, right? Now we can start the thread, right? So first approach is just by inheritance. Okay, by inheritance from the thread class, right? From
Yeah.
thread class. So notice the, here the thread class. So what the work I want run as a thread, right? Where I'm writing my code. This is the 5 line run in the separate thread, right? So I remember we have to give the override run method, right? Override run method. In this run method, whatever you're writing, that is your code written by or done by in the separate thread, right? So this is the method you have to override. Where why we have to override? Because this thread class we have to. This is a place where you have to write your business logic. Let's say I'm say loop I integer I equal to 0 semicolon I less than, that's 5 semicolon I plus plus, right? And here say s out message message plus message plus I, message 1 2 3 whatever, right? And by you can say thread name, which thread, right? How to know the thread name? Thread dot current thread dot get name, right? So this is the way you can understand which uh, threads this message is processed. Message processed by message one processed by the thread one, right? In this way, here in this run method, whatever you written, that can option to start by new threads. So let's say someone say I already have a class and I have a written method, I am created the object, then why I cannot call the run method, right? So last class if you call like my thread dot run, you can directly call, but in this case there is a no threading. This code is not executed by the different thread. Okay, so let's s out main done. Okay, main done. Okay, main done. You can also print the thread name here, which thread current thread dot get name. So this is the start. Okay. If you run this code, you notice I have a written this my simple class and written one run method. I simply call run. This means this is not any look like my class name thread, but really it is not a thread because you are calling a run method. This means this main thread. Notice all this message processed by the main thread only, right?
That's right.
And no, it's okay, no, I don't want the same thread do. I want to the separate. So I'm not going to call run. I'm say thread. So now this start method. Notice this my class, no start method, right? But still I can call start method. Why? Because this method is given by your thread class inheritance, right? So due to that, I can call the parent method. Now I can call start. So whenever you call start, now this start indicate our JVM. Hey JVM, here programmer want whatever the written inside this run method, that must be go to request in the separate thread, right? And if you run this code, notice this is executed by your thread different. Notice this is your main thread done, and now this is message processed by the thread 0, right?
Right.
So this is the okay. Till now, any confusion? This is just revision of the last class, right?
Right.
Okay.
So how did you get that output?
This is the
The
output. Let's check.
no, when you run
Uh,
that one,
So
thread zero.
that means here this code is executed by the main. Let's key printed by okay, printed by okay, which is just printed by. This is the main done by. Done. Whenever you run, so this line, whatever the written inside a main method, notice this is the main method our whatever written inside a main method is done by your main method, right? Main thread, right? But notice this code, I started new thread here, and what this class have, this class have one logic run. This code is processed by the separate thread, that is a thread name thread 0, not a main thread. So now your program is completed by the two thread. This is the thread 1, this is the thread 0, right?
Right.
So this code, whatever written inside method is executed by the separate thread. And this code in the main method is executed by the separate thread. But notice from main method, I can request to another thread, right? So main method is the place where you can start a new thread, right?
Right.
So this line requests JVM, hey, I want a new thread. So this code is written by new thread, right?
Right.
So this is the one way to create the threading, right? So there are multiple approach. So let's go to the second approach. Till now, any confusion, doubt to create the thread? And you can do multiple thread. Let's keep this is my thread and maybe I can write the another thread. Okay, another threads. Okay, maybe thread one, right? Multiple thread you will create, right? So you can create the thread one, and let's key similarly. I can S out. Okay, just demarcation, and here I can start the my. This is a new thread. Similarly, you can create any number of thread, right? So here say thread my thread equal to new my thread, and here say my thread one dot start. Here I am going to from main thread. This is the main thread. Main threads are going to start the one thread and another thread, right? Two threads. This is two times start I, right?
Right.
And let's run. So notice the same code is written by. Notice sometime this main is done main. Notice thread 0 run thread 0, then thread 1 come, right? Then thread 0 come, then thread 1 print, then thread 2 0, then 1 1 1, right? So notice the multiple threads, multiple message processed by the different thread, right? So even good option ki this code you can written in the some method, because both are the same thing, right? Maybe you can written in a separate code, maybe like here say I'm write the one simple uh, method. Maybe right here I write simple static void and process message, right? Process message. Okay, and just pass the integer, the number of process message you want, right? Your n. And here I just simply say ki whatever this code I am written inside this here cut. Okay, here, right? And here I pass your n, whatever the number of n, right? So notice the same. Now this method I can call from my thread. So say hey simple dot and just want to process 5 message, right? And same code I can do from here, right? So notice the same this code, same work. This is the same work can be requested to done multiple thread, right? So you notice this code is sometime printed by thread 1 and sometime this code is printed by the thread 2, because we are starting two thread, thread 1 and thread 2. Thread 1 what doing to thread 1 also doing the same task, and thread 2 also doing the printing the 5 message, right? So let's run. So in this way you can create any number of threads whatever you want. Notice. So notice here, this is the message 0 processed by the thread 0, message 1 processed by the notice this is the thread 1, thread 1, thread 1, all doing 5 work and similarly doing this work, right? So in this way, multiple threads are doing we created means multiple thread. One thing notice, once one thread is started, after that the thread will stop. And let's what happen, you go again start, right? So here compiler is not happy. If you run, compiler say your thread is already stopped. Why you're again starting? Once one thread is stopped, you can not start again. Notice here, you are getting exception, illegal state thread state exception. So one thing note, if one thread is started, after that you cannot again start. Because once this thread is started, what they're going to do, whatever written inside a run method, after this the thread is automatically dead, stop. Once one thread is stopped, they cannot again rework. So please be note that on the one thread object you cannot call 2 times start or 3 times. Only one time one thread can be started, right? Due to
Right.
that, notice I started two thread, thread 1 object and thread 2 object, right? Even, good option, even you can just create the same thread class 2 times. Is it also possible? I am just the same thread class, I create the different object. This is the maybe 2, okay? You can
Right.
do. See the my same thread class, but I can start the 2 threads. Though you have to create a 2 object. Please ensure that. Same time you cannot do 2 time starts. Okay. Here you have to start it first time, but you cannot again start the same thread again. Here you are trying to start. Compiler say no, this is the not feasible to start because your thread is started, and once thread done his work, after that again you cannot again start. Because whatever the task you written here, they have already completed, right? So why you are saying ki again do for me, right? So they say illegal state. So you cannot start again. Let's comment out here. And if you run code this here, it will throw exception because one already done. Again, you are trying to say start them. Notice they are getting problem, right? So what up alternative option? Okay, you are not allowing me. I can create the same object again. Notice here, I can create the same object again. Notice and just say again start. Now it's happy because you are going to create a new threads. New threads means just right. So in this way, multiple thread you can create for the same class or multiple class, right? So notice here you can create a, you have to, where the, you have to stop them, right? This is, we cannot start again. So sometime you already created one thread class, and in this case you can create, no, notice the multiple object they're creating, right? So here you can start any number of threads, maybe 2, maybe 3, right? This, but you have to always create a new object, right? It's clear. This class name is
Yeah.
same, just change the new variable, right? And start. So what is the purpose here? Means ki whatever the code written here in this run methods are executed. Whether you notice here, this is the thread 2, thread 0, thread 2, thread 0, thread 1, right? Multiple threads I can create it, right?
Right.
So this is the way. If you have written one class, and from this class you can generate any number of thread using this new object. Always create a new object for one thread, new object for new thread, new object for new thread, right?
Right.
But you not say ki I just one object and create start multiple time. No. Is it clear?
Okay. So you cannot open
Hmm.
uh, more than one.
You cannot is, once one thread is started, you cannot again restart the same thread. This is
Okay.
the one out thread. You can start it one time. After that, you cannot again say again start. You need to another object. Here I create another object and I say again start. So one thread are started only one time. I'm trying to say. Confusion?
Little.
What is?
So
Let us understand. So here I am going to create thread one. So this is the thread one created. Okay.
mhm,
One thread one created. And you say start. Whenever you're going to start, they are going to print the 5 messages. Message 1, message 2, message 3, message 4, message 5. And after this thread is dead. Completed. And again start. This thread already completed his job, then is not going to again start. If you want to same work again, then you can create again new threads. You can create again new thread, right?
okay, okay, okay. I see.
And
So
say
you cannot.
again start. So again going to print 1, 2, 3, 4, 5. Again after that start. Whenever
Right.
run method complete, it is automatically dead thread.
Right.
So here say ki new thread again. Again you are creating a new thread. Means new run method. Whatever again say dot start, they are going to printing this. Okay. So might be next here I say started thread 1, thread 2, thread 3, thread 1, thread 2, thread 3. So notice sometime I am getting thread 0 output, then thread 1, thread 2, sometime 2 by time, sometime 1, sometime 2, right? The multiple mixed output we are getting, right? Why you are getting?
Right.
Because all printing the same message, message process, message process, message process. By which thread? By thread T1, T2 or T3. So here I can start with 3 thread, the 3 threads going loop printing something, right? So let's they have done 2 loop, and after that CPU get this chance, then again they are going to printing. After CPU that get this chance, they are going to print it this, right?
Right.
So due to this, you are noticing our output have a kind of mix up thing, right? We are getting the same message processed by the multiple thread. Notice this is message 0 processed by the thread 2, message 1 processed by the thread 2, thread 2. Notice here again, thread 2 is not completed process 5 message. Now I get the thread 0 chance, right?
Right.
After again get thread 1 chance. Thread 1 again get thread 2 chance. Again thread 0 take, thread 1 take, thread 2 take, thread 0 take. Different notice the thread getting a chance. So each thread getting the chance to run, right? So this is the way you can write your custom thread. Means just create your class and extend this thread class and just write the override this run method to do, right? So now it's clear
Yeah.
how to write my own thread using the inheritance concept, right?
Yeah. It's clear now.
Now second option also have. Let's go to the second approach, right? And even you can create a multiple thread class, right? Here I can, instead of class 1, similarly I can create multiple classes, right? Multiple thread you can create, right? But whenever you're writing class, they are not any useful until you are not going to create the object and calling start method. Here I am going to create the object and calling start, that thread is started, right? Writing is class is just class, simple class, right?
Right.
But until you are not invoking start method, actual thread not started.
Right.
Correct. So let's understand the second way, the second approach. Second approach to create thread using the, here we are using the inheritance by inherit by inherit extended by the approach. First approach by extending, extend, right? Extend, right? Means inheritance. Here we are using extend keywords, right? By extends. Now second approach we are going to use the thread. Second approach of create thread by implements, by implements, implements runnable interface, runnable interface, right? The first approach by extend by the thread class, right? Inheriting from thread class, extend thread class by extend thread class, right? Means
Yeah.
inheritance. Is it clear? And here second approach, I am going to use the implements runnable interface. So here is the runnable interface, right? So let's check, this is the runnable interface. This is the very good, this is a functional interface. So functional interface can be implemented 4 way, right? By the subclass, by the anonymous class, by the lambda function, by the method reference, right? Is it clear?
Yeah.
Already we read this functional interface concept, right? Why? Because here you notice extend thread means by default thread class created, and class can be created object new, right? But here in the case of runnable, let's say allow new and say runnable. Not do, because this is the interface. You cannot create the object of interface, right? So how to cool? You have to first implement them. Why? Because this thread class have a one object method run. Who are going to what is the run definition? Because if you are create the object of runnable interface, if someone say runnable dot run, okay, run, what is the output? Because you have not given the definition of run method, right? This is the abstract method. So due to that, compiler are not allowed to create the object directly here. So you cannot do directly, right? So second approach, functional interface can be implemented by the functional interface can be implemented by the fourth approach. Already we know, right? Functional interface enable is a functional interface and can be implemented by four way, right? Can be implemented by four way, by the following way. Following way.
Mm.
So as we know, one by subclass means by implementation class uh, to by anonymous class, anonymous class uh, third by lambda function, lambda expression, and fourth by method reference. Okay, method reference. Okay. So these four approaches we have already covered multiple times, right? I remember, right? These things we have done multiple times. So let's again revise one more time, right? So question, let's with the simple approach first, then second, then fourth, then fifth. The first approach, what? You write the class. It's my runnable implements your runnable interface. This is a simple way, right? And here just override this. What you have to override? Override run method, right? This is the only run method you have to override. Here, whatever things you can write the code. Let's from here I am going to call the same method here, process message. Simple dot process and just pass the file. So this is my one way. So question is that my runnable object created, then how I can create the thread? How I can start as a thread, right? So basic question again. For starting thread, always you need to call start method, right? But this runnable don't have any start method. Notice. So how I can create my object, right? Here I say uh, my runnable equal to, now I can create the rest. I can create it. But question is that how I can start the thread. Hey dot start. There is no start method, right? So again, to starting thread, again we have to take the help of your thread class. Only again we have to take the help of your thread class. Thread equal to new thread. Okay. Notice, and now only this thread class have a start method, right? Notice start. Question is that whenever I am going to start thread, what they are going to print as a separate thread. Before I know ki this run method is going to the print. But here in case of thread class, I have to pass this my runnable here in the constructor. So now say, hey, I am going to create thread, but what is the task I am going to complete? Say, this is your task, runnable task. Okay, this is your task. You have to do this task. What is this runnable task? Runnable task is this is my work. This activity we have to do, right? Whatever the run method written here, right? Is out my runnable. Okay, plus a thread dot current thread dot name. So you can show it going to stop, going to stop. Okay. So notice ki whenever this run method going to start, runnable thread going to runnable thread going to start. So whatever this whenever run method call, this thread going to start. Whenever run method complete, this thread going to dead automatically. Whatever here written code that works fine, right?
Yeah.
So here whenever so whenever you write runnable, this have not any start method. Then again we have to take the help of a thread class. Thread class create the new thread class object and say, hey thread class start. So whenever new thread is started, what they are going to print? You pass this is my task. Please call this method, right? By default, this thread start class start method internally going to call the run method. Notice whenever we are doing here thread dot start, they are internally going to start your this call the run method. Notice here run method. So let's test. Okay, what is this saying? Okay, they are saying write in separate method, not in this one. Okay, so let's now I am going to test. Let's as of now just comment out all the things. So right. Okay. So now I am going to just writing my runnable object first, and then I create the object, and then say, hey thread class, just start, and while you start, you can call the run method of my object. This is the my object, and this is the run method. You have to call this, right? Let's test. So this is the another way to create our thread. Notice now here your runnable is started and all the thread 0 done and stop, right? So this way, notice I'm not calling this run method, but the run method is invoked by our my thread. I'm just calling it start, but start internally going to create first new threads and on those new threads say, hey, please run this code, right?
Right.
Any doubt? The second approach to start thread using the runnable task. Is it clear?
Yeah.
And sometimes someone say, I can implement by the anonymous class. I'm not going to write this complete class. Even I say simply say, I am going to write the anonymous class. So what is the anonymous class? What is the here?
Anonymous class is like you just type the
Right. Just
method and then
yes,
arrow.
just
Uh,
this is the complete code, right?
yeah.
This is the anonymous class. And here anonymous means without name. That means these things I'm not going to use, right? So
Yeah.
anonymous means whatever the these things, whatever the these things, see the things, whatever this is thing, just same is the anonymous, but I'm not giving the name here, right?
Right.
So I'm not giving the name, then how can create the object? They say just create a new, okay, new, just say new, just use the interface name itself, right? And here assign the same in the object. Runnable, runnable, anonymous. Okay. In this way, just make the equal to a sign. That's this is your anonymous class list. I am not going to just now here semicolon, right? So this is your anonymous implementation. What is this? Is the anonymous implementation. Now we have a runnable object. Question is that how we can start thread. So let's comment this line, okay? And I can say, hey, I'm not going to start this thread. And say here again, start method only have a thread class. So here also you have to take the hey thread is equal to thread 2 equal to new thread semicolon and thread 2 dot start, and here you can pass what this my anonymous body. Say whenever thread going to start, print this one, right? So look like whatever this implementation class or anonymous class look like a same thing, just we are not using the any extra name, just I'm using the runnable interface itself, right? If you run, it will print thread by anonymous way. So notice this is my code printed by the thread one, right? And this is the anonymous, a good option. Even you can write this code completely here itself. So instead of this way, you directly say here. Here say thread th thread 3 equal to new thread, and here this code completely you can write here itself. Completely write the inside the body. Both are the same thing, right? It's work fine. You can write this way or you can write this way, the same thing. So here say I'm going to thread object and this is my task. And now you can say thread 3 dot start. Now your thread started. This is the right different way of writing code. Notice it started by thread 2, right? Even you can go with the third approach using the lambda expression. Lambda expression say why you are writing unnecessary the new interface override something something. This is a business logic. Only write the business logic, right? So even instead of writing this code, even we can more concise. I'm say, hey, this is thread 4. I am going to start thread 4. Thread 4. Here I am not going to interested all these things. This is the unnecessary thing, right? Just remove them and just make one arrow. This become a lambda expression, right? So now we are implementing third way using the lambda expression. Lambda expression say don't use the this runnable override run method. Why you are writing? Already I know that this interface is runnable, so we have to override the run method. So here say just give the logic, right? And this is using the lambda expression. Lambda expression, right?
Right.
For concise and run, you are getting the lambda expression output. Right? This is the by lambda, right?
Right.
So now, if your thread have only one liner code, even you can remove all this open closure, right? And the simple way, say, hey, I am going to say thread, it's 5 equal to new thread, and here we have just because of thread, okay? And here directly you can write simply say, hey, this is my lambda expression and this is my code, and just system dot out output and whatever output, right? Okay, lambda expression by
Yeah.
whatever give the message learner by plus thread dot current thread dot get name. Even one liner you can also do.
Lambda
If you
space.
can writing this code in a one liner. Say, hey, thread dot start. Now you can start another thread, just one liner. Maybe here one liner, I can call this method itself from particular business logic. So generally one liner not a business logic, right? So good option, instead of writing this, I say, hey, I'm not going to write this way. I'm going to just write this. I'm calling this complete method, right? I'm just one liner, right? I say simple dot my process number 5 element, right? So this is
Yeah.
the six sixth thread, okay? Right. So this is the way this is the code I want to in a separate thread. Simply say, hey thread, using the lambda expression, I'm just calling this method, right? Okay, and you can just simple. This is the thread, and this is the method I want to process. Okay, this is the multiple thread. Even now we can move to the next step. Already we have a code written in a method, so why can use that not use the method reference, right? So here say, let's instead of writing this way, I simply call the method reference. Why use the so here let's save in and say no, I don't need this. I even not lambda expression. Already a method reference. I call just simple. So let's one thing here, math simple dot, okay, and here whatever the value I pass here, and let's I think I right no
That's lambda, right?
lambda is done here. I'm not going to lambda is sufficient. I am going to use the method reference. Method reference say, let is a example to give method reference. This is the method reference example, method reference, okay?
Right.
And method reference say, hey, just I want to call this method as a method reference, nothing, okay? Even more concise way using the method reference. If I say this is the method, you can call them, right? And even this is the more concise way, right? Just has thread. This is the method. Okay, this is the process message method. Okay, method method. Just you okay? Just you call this method. I want this code run in a separate thread. So thread class. This is the method. Just start, and you can start at the thread, right? So these are multiple approach. You can just start the thread, right? So this is the method reference. This is the lambda expression. This is your anonymous class. This is your extend implementation class. So you can say now second approach is to create thread by implementing runnable class. We have a four option to implement interface, right? This is why implementation class. Just create the implementation class, create the object, and create the threads and pass this object, right? Second way, anonymous class. Okay, even you can anonymous class can be written inside the constructor itself. Here inside the constructor thread class, I can pass it. Or even better, why I'm going to write unnecessary stuff? Why not use a lambda expression? Because this runnable is the functional interface. A functional interface can be implemented by the lambda expression. So why I'm going to anonymous class or implementation class? I can implement the same thing with the lambda function. So here say this is a lambda expression and this is the business logic. And business logic is the only one method. So simply say call the only method, right? So this is the method using the lambda expression or using the method reference. Why method reference work? Because notice this thread class are expecting the what kind of input you pass the runnable. A runnable is a simple method that does not take any input and not call any output, right? So notice I am written the some method. This is a method that does not take any input and return void, right? So this method is the candidate for your method reference. The method reference you have to check thread class what kind of method expecting. So notice here thread class, go to the definition, say they are expecting runnable and runnable have a method run. Run is the no input parameter and only void. If any method that follow this syntax, we can pass here. So this is the my class, this is my class, return void and no input parameter. So this can be called as a method reference. So here say, hey, simple, call this is a method reference. And just print. Now say, now this thread class is going to call my this method. They are not going to call in the run method. Notice here is no, in this case, there is no run method. In these two cases, there is no run method, right? This is the run method definition. This is the run method written by the maybe different code right here. So using the method reference or lambda expression, you can call any methods that follow the syntax of your thread. Thread are expecting runnable object. Runnable means any method that have a return type void and input is a blank, null, no input. So those is the candidate for your thread class. So if you talk about the initially you started whenever you are going to call any start method, here say I say thread dot start. That means internally this start method going to call your run method, right? This is the run method they are going to call, right? This is the run method. But in the case of method reference or lambda expression, there is no run method. Just this is the method you want to tell. Hey thread, you can just call this method. Hey thread, you call this method. Why you're just calling the run method? You can call any method. You can run this code as an independent thread, right? So this is the more highly used. Means ki now I'm not only always focused to call by the run method. Even any method, maybe process method, yeah, process only process message, yeah, process message method can be run as a separate thread, right? So is it clear?
Yeah.
Any confusion? So
I mean,
even so whatever the code you want to run by separate thread, you just write the method. I mean, this is my method and return type void, void a method name, anything, any method name, any method name, okay, method name, and you can call here and just write as out whatever the message you want, right, to print them, okay. Okay, so just write any number of line here, whatever. This is the anonymous one, one, two, three. So sorry, two, what happened? Two. I'm trying to say कि whenever you want any code that you want to run in the separate thread, just write in a method that follow the syntax void and no return any value. And this can because you want to run separate thread, that means you have to call the start method, right? So you have to need the thread class thread 8 equal to new and thread class and thread 8 dot start. Surely we have to call the start method. The question is that this thread are going to run which code. So say you say this run my this code. This is my I this is the method I want to run. Okay. I should say method name, give the method method run in new thread in separate thread, right? Whatever the name you give, this method you can call here. Sample dot just. Now your thread class going to run this code as a separate thread. So very simple way, whatever the code, whatever the line, whatever the method you want that run in a separate thread, you can just pass here as a method reference, right? Thread class, method reference, and dot start. Because you don't know how to I can start new thread. But this is the start method. Always you have to call to start a new thread. But whenever you call start with the thread one, thread it, you have to tell, hey thread, you can run this my code, right? So this is the simple way. Whatever the method, whatever the task, whatever the work you want that should be run by. Notice this is the separate thread run by the seventh thread, right? So let's say start. Okay, stop them. So here I'm trying to say for starting any code you want that run by separate thread, a different thread, a new thread, you don't need to just you have to call the start method of a thread class, and you tell, hey thread class, please use this my method in a separate thread, right? So there is no here there is no any kind of a runnable implementation, there is no any kind of inheritance, right? Here not I'm going to inheritance any, here I'm not going to use any runnable interface. I'm just say ki this is the my method I want to run in separate thread, right? So look like here you are not implementing any runnable interface, or not implementing, not extending, but internally look like this is the implementation class of your runnable interface. Notice here in the runnable interface, what are you doing? This is the writing class run and writing this code, right? Writing this code, writing this method. This is the same as your just name. Now void run open close. Now this method the same syntax. Void, not a run, just syntax. They follow the same syntax. Due to that, our thread class is able to call your method as well as, right?
Right.
So whenever you say thread dot start, internally they are going to the call run method, but there is no run method here, right? But thread internally assume you are passing me method that is the run method for me, and they are going to call this method, right? Because run method syntax is same as this method, right? Run method as void and no input, right? Notice the run method, void and no input. The same is the
Right.
here, void and no input. Due to that, our threads are going to treat your this code as a runnable task, as a run method, and they are going to the call your method. So today we learn how to create separate thread, new thread. For that, you always use to thread dot start method, right?
Right.
And whenever you say thread dot start, thread class is written with the JVM, Java language. The Java designer don't know your method name, na? Ki this is which code you want to run in separate thread. What is your work? Which work you want to done by the separate thread? The thread say, hey, just tell me your method name. I am going to do for you. So here I am going to start and say, hey thread, whenever you're going to separate thread, this is my method you run in the separate thread. So this is a very simple way to write a thread, right?
Yeah.
Same code you can written in multi-thread. Say similarly, you can say same thread 2 and just start thread 9, right? 9. Okay, it works. Now this code is written by two threads. One is the line 1, 2, 3 is print by one separate thread and one separate thread. So now I have only one work, but I want to say, hey work, take that means I say, hey, I'm going to start one thread, thread 1 and thread 2. And both threads, what they're going to do? I'm saying, hey, this is your method. So all these codes are here, place 4 line. Here also place here. So now this thread also have this 4 line, and this thread also have 4 lines. Whenever I say thread dot start means they are going to print. They are going to the print both simultaneously. Might be first you get this output, second this output, might be this output, might be this output, or this thread get higher priority, higher chance than maybe I first print all these things after that this, or might be sometime this will first go first, this will go first part. So please note the output of your multi-threading is not guaranteed order, right? Why? because we as a Java, as a JVM requesting operating system, hey operating system, can you execute code for me? And depend upon the operating system bandwidth, they are allow you to use my CPU, right? So
Yeah.
as a Java, just requesting, hey operating system, can you give me your CPU chance so that I can run my code? Okay. So notice here 7 7 two time, then 8 one time is 7, then 2 8 time, right? Again the code run might be different order. So notice 7 7 first, then 8 8 first, right? Again run. So output of you notice here 7 7 double 8 7 8, right? So each times you run, you are getting a different output. Why? Because your JVM requesting to get CPU for running my code, right? And depend upon the or operating systems give a chance. And operating system doing lots of work now, right? Lots of services running on your system, right? Go to the task manager, check lots of program running, right? So
Right.
depend upon the maybe some second, millisecond up and down, lots of services, lots of processes running in the system. Similarly, one JVM process, right?
Yeah.
So please, later question, I'll discuss multiple approach, but as of now, understand this is a simple way to start in multi-threading in the Java. Simple. Whatever the code you have, just tell hey method to the thread class, and thread class invoke the start line. This two-liner code is sufficient to start new thread.
Got it. Yeah.
Okay, but before reaching, you have to understand why we reach here. Lots of approach going to here. 'Cause initially
Right.
days, whenever first time, always we start with like a criteria class, implementing, overriding, run. But this should aware behind the thoughts all is going. But Java day by days are going to make developer life as easy as possible, right? Even coming classes, we are going to understand. Even we don't need to start method, right? We're going to discuss. Even they will Java designer giving the more flexibly, more easy option to the Java developer to do multi-threading, right? But as of now, you understand, you want to start thread, you have to use the start method of the thread class. Okay,
Yeah.
so let's revise these things, work them thing. Any doubt, any confusion, we have to connect. Why
Sure.
I discuss here four approaches? Because we already learn what is the functional interface and how we can implement it. Due to that, I am saying here just revise this four way we can implement runnable interface, right?
Right.
So that's for the day. Anything you want
Yeah.
to ask?
That's good.
Okay. Take
Yeah.
care.
Take care.
Great. Bye.
Bye.